Okay, so I guess I'm just going to be able to talk about graphing a little bit because my tablet does not let me draw. So I'm just going to talk about stuff, and hopefully my mouse will kind of respond a little bit, or my pen will respond a little bit so you can know where I am. But anyway, whoops, and didn't want to do that. Okay, so let's talk about this a little bit. First of all, the square root of x graph normally would go from 0 to 0 and then kind of go out like, sort of like a half of a quadratic equation, which is called a parabola, half of that. But because of this minus sign here, the graph's going to flip, and because of the plus 4, remember anytime we affect the every time we affect the x, we do the opposite. So we're going to do the opposite. That's why this whole thing, instead of from 0, 0, is now at negative 4, 0. And then again, you're going to go to your graphing calculator, type this in, all right, and then go to, and everybody here should know how to put this in the calculator, but you're going to go and put it in and graph some points, and pick some points you can easily put down. And these are all easy points. There's no decimals, no fractions. So let's talk about the domain, the range, and all the way down this page here. All right, talking about the domain. The domain is basically all the set of x's that you're allowed to put in that you're actually going to get a graph out. So if you don't see a graph there, then there is no x. So for over here on the left-hand side, where you see this right here, there's no graph there. There's no graph there. That means there's no x and y value that'll make it true. And the reason being is the smallest square root we can find is 0. So that's why if I put a negative 4 up here next, negative 4 plus 4, I'm going to get 0. And that's the smallest square root I can find. So you're always going to have a starting point with the square root radical graph. It always has a starting point, and it just keeps going in one direction. So in this case, it's starting at negative 4, and as long as I see a graph, that means all these x values that are along this x-axis are all being used, because as long as I can see a graph, that's good. So basically, from negative 4 on, I'm allowed to pick an x. I can pick any x, and if I look up their y value, it'll be on this graph down here. And that's what this means up here. This says x is a member or element of the real numbers. Real numbers is a fancy R. And it's saying, in order for you to be in the club, you have to be a value that's greater than or equal to negative 4. That's what that means. All right, so that means every x that I pick has to be negative 4 or bigger. The range. Now, if you notice the range, there's not. I mean, y can only be so small. We talked about this before. If I take the square root of a negative 4, I'm going to get 0. So the smallest value I'm going to, excuse me, the largest value I'm going to get is 0, because all the rest of these are going to generate positive numbers, and this minus is going to make it negative. So this minus right here is going to change everybody to a negative, and that's why y always becomes negative. And y keeps on going and 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 going down. So, but the largest value is 0. So that's why it says here y is allowed to be a member of the real numbers. And this line here means such that, by the way, means, hey, in order to be a member of this set, there's also a member of this range. Not only do you have to be a member of the real numbers, but you also have to be less than or equal to 0. Okay? The zeros are the same thing as the x-intercepts. It's the place where the graph hits the x-axis. So you say negative 4. If they ask you for an x-intercept, you just put y as 0, because again, whenever you hit the x-axis, y is equal to 0. When they ask for the y-intercept, they want to know when x is equal to, or when when x is equal to 0, what's y? This value right here could actually be looked up in the table. All you have to do is go to look up the table, look up 0, and the negative 2 will pop out right there. And if you want to take the time to go punch this in and look at it, you'll see 0, negative 2. So you don't really have to do any math. Increasing and decreasing interval. You're describing to me the set of x's that are making the graph go up or go down. And increasing means you want to know what x's does this graph go up. Well, there is no, because you read from left to right just like a book. There isn't any part of the graph that's going up. That's why we don't have an interval. The decreasing says it starts from when x is negative 4, and it keeps on going. If I pick negative 3, negative 2, negative 1, 0, blah, 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 y is going, it's dropping. So this is saying x has to be from negative 4 all the way to infinity. Okay, that's the interval. And notice I don't say equal to because at this point, at this first point, you're not increasing or decreasing. It's sort of like your starting point. My analogy was either a roller coaster ride or a ski slope. You're gonna ski down the mountain. If you're at the top, you're not increasing or decreasing. You're hanging out there waiting to go. The end behavior has to do with what's going on with these arrows. Okay, so as x is getting really big, aka as x is getting larger to the right on the number line, what's y doing? Well, y is slowly getting smaller and smaller and smaller and smaller, and it's approaching negative infinity. Now, I want you to understand infinity and negative infinity. Infinity means really large numbers, and y approaches really small numbers, and that's all you really need to get out of that. And then it says here as x approaches negative infinity. Well, x can't go negative infinity because it can only start at -4. So it can't get forever negative. It can't do it. So we would say that this doesn't apply to this particular function. So let me go to the next function. Hold on a second. Okay, so this is a cube root function. So negatives are allowed. Positives and negatives are all allowed, not like square roots where we weren't allowed to get a square root of a negative, but here we're allowed to do a square root of a negative. So what you need to know is the cube root of x normally would start at 0, 0. Most functions other than the exponential and log functions, which we'll learn about, and also rational and inverse functions, those functions which we haven't done yet, don't have to start at 0. But all our other functions that we've been working with all start at 0, 0. Anyway, so we normally would start off at 0, 0, but again, this 2 on the outside, remember, it's outside the radical. The 2 means that, again, then it moves, the whole curve is going to move up, and if this had a plus or a minus inside the radical, it move it left and right. But since I'm not doing that, I don't have to worry about it. Now this, basically, not that you really have to know that too much, but basically what will happen is this thing will shrink. So it's going to get squashy a little bit. But you don't really need to know that as much as the moving up and down and left and right. That's the most important part. So anyway, so we're going to look at all these. And again, I graph these by just picking some points off, making sure I get this shape because I know the shape. If you notice, if you tilt your head, it looks like a cubic. Remember when we did cubic functions? It kind of sort of looks like that. And cube root, sort of like the way x squared looked like the quadratics, the x squared graphs, the cube roots look a lot like the cubics. Anyway, so we just plot a bunch of points so you get that kind of curve look there. I mean, I looked up every single one of these points right off my table, so I would just type this in. Remember that when you go to type this in, there has to be a parenthesis right after that, the 2x. Otherwise, it'll continuing to put this square root over this +2, and that won't give you the graph that you want. It'll actually move it somewhere else and not move it up. So you want to make sure you put that in correctly. All right, so the question first is, what x's am I allowed to pick from? Well, if you look, any x that I pick has a graph above or below it. So that means that x is allowed to be used everywhere. Okay, so that means if I were to pick any x from every single one of these boxes, we're going all the way across here, has a graph above it, below it, on it, but I still have something. It wasn't like the square root graph, which if I could screen that back real quick, the square root graph, see how it doesn't have any graph over here, so therefore x doesn't get to be anything. Well, on this graph, we're going everywhere. We don't have any gaps in our graph. It's continuous, totally continuous. All right, and then the y's, if you notice, as you go to the right, y is getting larger and larger and larger, and when we go this way, y is getting smaller and smaller and smaller. So the idea is that the range gets completely covered as well. There's no limit as to it doesn't have a limited range at all. Okay, zeros again are where you hit the x-axis. Here it hits it at -4. If I'm being asked about an x-intercept, all I have to do is put it as written as a point. And again, anytime you're looking for an intercept, the other letter, if I'm looking for x, then y is 0. If I'm looking for the y-intercepts, then x is 0. And again, this one right here, I could go look. If I didn't have it graphed, I could go look it up in my table if I wanted to. Whew. All right, so now we have increasing and decreasing intervals. So my question is reading from left to right. The confusing part is you see the arrow even though it's pointing down. My question to you is as I'm going this way, what are you doing? If I were driving from here up to way up here, wouldn't I have to increase the whole time? Now it's not as it's slight here and then I get to here and I go, oh wow, I got to go up really high, but I'm still, no matter what, if I keep going, I'm going to increase. So the increasing interval is pretty much everywhere, from negative infinity all the way to positive infinity. The entire time it's increasing. Okay, decreasing, obviously, if it's increasing everywhere, it can't decrease anywhere. Now, the end behaviors, I kind of treat this as I have two arms. Okay, I have a right arm here and I have a left arm. My right arm is my x going to infinity, and my left arm is my x going to negative infinity. So if I'm going to positive infinity over here, what's my y doing? It's growing. It's going to positive infinity because it keeps on going, keeps on going, keeps on going. As x is going to negative infinity, that's going off to the left here. What's y doing? It's dropping. So that's why I have negative infinity. Remember, infinity means a really large number, and negative infinity means a really small number. Okay, and that's about as much as I can talk about this on the computer. But hopefully that helped out.